Hey everybody, welcome to today's video, which will be 50 derivatives. This video is inspired by Black Pen, Red Pen, so please go check them out because they're amazing. Alright, and also something to note is that some of the derivatives, I won't be simplifying them to its simplest form. I'll just leave it as is after the rule. Yeah, and let's get to it. So first things first, d over dx of x squared. Fairly simple, you just use power rule, and we'll get 2x, right? That's your first answer. Now let's go to the next question. We've got the d over dx of x squared plus 3x plus 5. Here we can also use power rule for each single one to solve this. So here we'd get 2x, right, plus 3. This 5 won't exist. So this would be our answer for this one. Alright. Okay, now we have an instance of product rule. Now, there's a few ways to solve this, but I feel like product rule would showcase something really cool. So let's do it. So first things first, you take the derivative of this one over here, which in this case is going to be 12x squared, right? And then you would want to multiply that by this without taking the derivative of that. So it's going to be 12x plus 3. Now the order doesn't matter because it's addition, right? And we're going to be adding to it the derivative of this one, which is going to be 12, times just the regular 4x cubed. And I'm just going to leave it like this for now. So that's our answer. Okay, so here for question number 4, we've got the derivative of 1 over t. So to take the derivative of 1 over t, that's what we're going to do. I'm going to rewrite this. So it's going to basically be the same as is equal to the derivative of t to the negative 1. All right, so let's take the derivative of t to the negative 1, so d over dt. Oopsies, I'll just do it right here. Oops, so it's going to be equal. We use power rule, we're bringing this negative down, so we're getting negative t, and then it would be negative 1 minus 1, which would be negative 2. And you could potentially simplify it from here, but I'm just going to leave it like that for now. But I'm 99% sure you guys know the way to simplify. Okay, so now here, for question number 5, we have an instance of chain rule. Now, why would I say chain rule is because you can see to the power of 8 and we have something inside brackets. So let's do this. What I'm going to do is I'm going to set my y equal to u to the 8, right? And I'm going to set my u equal to whatever's inside of this. So it's going to be x cubed minus 3x squared plus 4x minus 5. And therefore my derivative, so du is going to be equal to 3x squared minus 6x plus 4. This is going to be my du. Alright? So it's going to be u. So remember, the derivative of this, of y, so dy, let me put it right here, dy is going to be equal to 8u to the 7th. So now we can substitute everything together to get our final answer. Where our final answer is going to become, let's do this, so we're going to have 8u to the 7 multiplied by du. So it's going to be 8u to the 7 multiplied by du. So, which is, in this case, 3x squared minus 6x plus 4. So let's put in our u back in, which is going to be 8 times x cubed minus 3x squared plus 4x minus 5 multiplied by 3x squared minus 6x plus 4. Now let's take the derivative of 7 tan 5 theta. So this looks like I should use chain rule. So what I'm going to do is I'm going to set my y, so I'm just going to go here, I'm going to set my y equal to 7 tan u, right? And my u, in this case, is going to be equal to 5 theta, right? I think, is it good? There we go. So I've got u to 5 theta. So now what I want to do is we're going to take the derivative, which is d over d theta, of 5 theta. And then we're going to be multiplying it with the derivative of my 7 tan u. Right, so this becomes just 5 on its own, and then here we have 7 tan u will actually become 7 sec square u. So we're going to have 7 sec square u. Now all we have to do in this case is sub back, or actually we can just multiply these two together, so we get 35 sec square u, and we can sub back our u in this case, which is 5 theta, so we'll get this to be 35 sec square 5 theta. And that should be our final answer in this case. There we go. Alright, now let's go to the next question. We've got the d over dx, which is the derivative of sine inverse of x plus cosine inverse of x. So we can first take the derivative of sine inverse of x and then take the derivative of cosine inverse of x and see what happens. So actually the derivative of sine inverse of x, it's important to note that it's actually equivalent to 1 over, let me write that down, 1 over square root of 1 minus x squared. Sorry for the bad writing, let me fix that up. Square root of 1 minus x squared, all right? And then here for our cosine inverse of x, it'll actually be equal to -1, right, over square root of 1 minus x squared. Now, if something cool happens, right, these will actually cancel out, and you'll get our final answer as 0 for the answer here. All right, so now let's move on to our 8th question, which is the derivative of 4 cos h cubed x. So how can we solve this one over here? So what I would want to do here is I would want to set my u, right, equal to cos hx. I think that's a good u. And in this case, my y is going to be equal to 4u cubed, right? So I'm going to take the derivative of cos hx, right? And I'm going to take the derivative, multiply that by the derivative of 4u cubed. Sorry, this should be a y, because we're taking it in terms of y. Sorry, no, d over, sorry, this should be a u. What am I doing? Okay, so now we have the derivative of cos hx, which is going to be sine hx, and the derivative of 4u cubed is going to be 12u squared. So we can sub our things back together, right? I'm going to bring this up front actually, so because it has a square in front of it, so it's going to be 12 cos hx squared, right? So cos h squared x multiplied by sine hx. And that is it to solving this one. So here we're being asked to take the derivative of sine theta plus cos theta over sine theta. So here we can see that we can't simplify this further, so let's get straight to solving this with quotient rule. So what's going to happen first is I need to identify my g theta and f theta, right? So in this specific case, my g theta is going to be sine theta, which is the bottom. I'm just going to put an arrow here. G theta. And this is going to be my f theta. Alright? So it's going to work. I'm not going to take the derivative of this first. It's going to be sine theta alone. It's just going to be g theta. Multiplied by the derivative of, so we're going to do d over d theta of f theta, which is going to be sine theta cos theta. Right? Sine theta plus cos theta, actually. Subtract, right? Sine theta cos theta, sine theta plus cos theta, actually. Plus cos theta. And multiplied by the derivative of sine theta. And this entire thing should be divided by g theta squared, so it's going to be divided by sine square theta. Alright? Okay. Now what's going to happen? Now let's simplify this even further. We're going to have sine theta, right? And the derivative of sine theta plus cos theta, you just take it individually, is going to be cos theta, subtract sine theta. So it's going to have cos theta, subtract sine theta. And then here we're going to have minus sine theta plus cos theta. And the derivative of sine theta is just going to be cos theta. Okay, and this entire thing is divided by sine squared theta. scroll down a little bit. Now, what we need to do is we need to, I guess, put some terms that we know together, right? So it's going to be, or we can actually distribute, actually. I think that's what we should do first. We should distribute. So it's going to become sine theta, cos theta, sine theta, cos theta. And then it'd be minus sine squared theta, right? And then here, this is going to become minus sine theta, cos theta. Sine theta plus sine theta, cos theta, right? It's because these are going to go together. And then you would have a cos squared theta. Okay? And it's still going to be divided by sine squared theta. Alright. So now what we're going to do is, once we put all the like terms together, we'll get minus sine squared theta, right? Minus cos squared theta divided by our sine squared theta. And this is going to be equal because we'll get a an identity, right? Sine square and cos square give us an identity. Remember, if we do, will give us an identity of 1, right? So remember, sine square theta plus cos square theta equals 1. So we're basically using this identity over here. But since it's minus, it's going to be minus negative 1 over sine square theta. And negative 1 over sine square theta is equal to negative cosecant square theta. The reason why I showed all my steps for this one, because I thought this was a really beautiful derivative. So yeah, that's it for question number 9. Alright, so question 10 asks to state the derivative of e to the x natural log of x. So what we want to do is product rule, because multiplication involved, so let's do that. So it's going to be equal to, let's say, e to the x, right, multiplied by natural log of x. Right? The reason for is because the derivative of e to the x is e to the x, right? Plus, we're going to be adding e to the x, right, multiplied by 1 over x, which is the derivative of natural log of x. So we're going to get e to the x natural log of x plus e to the x over x. So now what are we going to do now? Now if we put all this together, we can factor out a value of e to the x. So we're going to get e to the x outside. And then we're going to get natural log of x plus 1 over x. And that is going to be our final answer. So I'm just going to circle that in red, because why not? Okay. So now for our next question, we've got d over dx derivative of x minus 2 multiplied by x minus 1. So for this one, I'd generally just FOIL and then solve it regularly. But there's probably another way to do it. But let's do that. So we get x squared minus x minus 2x, and then you get plus 2. So then you can suppose x squared, so this is x squared minus 3x plus 2. So what I'm going to do actually is not equal to it, but rather I'm going to be taking the d over dx of this. It's the same thing, right? D over dx of this. So this is going to be equal to 2x minus 3. That's it. Should we red real quick? Okay. Now for our 12th question here, which says to take the second derivative. So you have the square here, a little tricky. It asks us to take the second derivative of x to the 7 minus 3x to the 5th plus 5x cubed minus 7x. So the first things first, I'm going to take d over dx of x to the 7 minus 3x to the 5th plus 5x cubed minus 7x. So it's going to be equal to 7x to the 6th minus 15x to the 4th plus 15x squared minus 7. So, and then therefore, then my d squared over dx squared, actually before that I'm going to take the derivative of this. So I just proper of 7x to the 6th minus 15x to the 4th plus 15x squared minus 7. So this is going to be an answer of 7 times 6 is 42, right? So we get 42x to the 5th. And then 15 times 4 is 60. So we get minus 60x to the 3rd plus 30x. And then the 7 will potentially just disappear. So this is our answer. So we're going to just write out here. D squared over d, put a little dx squared is going to be equal to 42x fifth minus 60x cubed plus 30x. Okay, that should be our final answer. Alright, so here for question 13, we're being asked to take the derivative of x squared plus 3x minus 4 over 2x plus 5. So what we need to do here is we need to use quotient rule. So we can determine that this is going to be our g of x in this case, this is going to be our f of x in this case. So let's get to kind of solving this. So I'm going to have my g of x, so it's going to be 2x plus 5, multiplied by the derivative of my f of x, which is going to be d over dx. Let's write down everything first, of x squared plus 3x minus 4. Right, we're subtracting out x squared plus 3x minus 4, right, all multiplied by the derivative d over dx of 2x plus 5. And it's all going to be divided by, oops, I have an x's back bracket. It's all going to be divided by a value of this squared, so it's going to be 2x plus 5 squared. Alright, so now let's get to solving it. It'll be 2x plus 5 times the derivative of this, so it'll be 2x plus 5 times the derivative of this would be 2x plus 3. Subtract out, you have another derivative here, so no derivative here, so it's just x squared plus 3x minus 4. Derivative of 2x plus 5 in this case, again, it's just going to be times 2, right? And it's just going to be divided by this squared, so it's going to be 2x plus 5 squared. Now I'd leave it like this because expanding it would be a little bit annoying. So yeah, you guys can expand it yourselves if you guys would like. But yeah, this is basically the main part of this derivative, so I'm just gonna do that. Alright? I'll put a dot 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 because it can be continued. Alright, so here we have a derivative. I guess it's a little bit more of a simpler one, but some people could find this tricky. So here we'll just take the derivative of this one, and then take the derivative of this one, and then just do a subtraction between them. So derivative of 1. What is the derivative of 1? This is something to think about. What is the derivative of 1? Right? So the derivative of 1 would be 0. And then derivative of u would just 1. So what is 0 minus 1 in this case? Negative 1. So answer to this question is negative 1. So for question 15, it asks us to take the derivative of 4 plus x to the 9 multiplied by 2 minus x to the 5. So the base of this is going to just be product rule with an involvement of chain rule. So we're going to have to use both of these to solve this. So what I'm going to do is I'm going to rewrite this as the derivative. So it's going to be the derivative of 4 plus x to the 9 multiplied by 2 minus x to the 5th, right? Plus, we're going to have the derivative of 2 minus x to the 5th multiplied by 4 plus x to the 9th. So the places that we are going to need to use chain rule are basically here and here when we're taking these individual derivatives, right? So let's do that. When we take the derivative of 4 plus x to the 9, so I'm going to just do it right here so you guys can see it right here. So instead of taking the derivative of 4 plus x to the 9, I know my y in this case is going to be equal to u to the 9, correct? My du, right, is going to be equal to 4, which is going to be equal to 1, correct? And in this case, my u is going to be equal to 4 plus x, right? I forgot, I should have wrote u first before I did my du, but yeah. So now when we put this together, we're basically going to get, oh yeah, we also forgot to do dy. Our dy is going to be equal to 9u to the 8. So when we put this together, we're going to get 9 times 4 plus x to the 8, right? And then we're going to be multiplying it by my du of 1. So this is basically my final answer, 9 times 4 plus x to the 8. Alrighty? Okay, now let's do 2 minus x to the power of 5. So let's do the derivative of 2 minus x to the 5, where our y is going to be equal to u to the 5th, right? and then my u is going to be equal to 2 minus x, right? And therefore then my du is going to be equal to negative 1, and my, in this case, my dy is going to equal to 5u to the fourth. So putting everything together, we're going to get 5 times 2 minus x to the fourth, right? Multiplied by my d, which is negative 1. Alright, so now we're just going to put everything together, and when we do that, we'll see that this negative will come here, so we'll get negative 5 times 2 minus x to the fourth. Actually, you can take this negative out and put it somewhere else. So actually, forget about that. We'll worry about that later. So now let's finish up our equation here. So this is just going to become 9, right? 9 times 4 plus, oopsies, 4 plus x to the 8. And we'll have 2 minus x to the fifth, as usual. Plus, we're going to have, actually, this is where I'm going to replace my plus with a negative, because of the negative 1. We're going to have 5 times 4 plus x to the 9th, right? X to the 9th power, right? And we're going to have 2 minus x to the 4th. I just brought this 5 to the front. No other differences than that. It should basically act as the same exact equation. So this is going to be my final answer. You could probably simplify this further, but for now I'm just going to leave it like this. This question, it asks us to take the derivative of root x plus 2x over 7x minus 4x squared. So the best thing to do for this is actually to make this simpler by changing our square root to x to the half. So let's do that. So this is basically the same thing as saying the derivative of x to the half plus 2 to the 2x divided by 7x minus 4x squared. So now what do we need to do? We need to use quotient rule in order to solve this, right? Here, quotient rule. That's probably all that we need. Alright, so this is basically going to be equal to the derivative of the top, so it's going to be d over dx of the top part, which is x to the half plus 2x, which is this basically, I forgot to do this. This is my f of x, this is my g of x, by the way. Okay, so it's going to be the derivative of this multiplied by 7x minus 4x squared plus subtract the derivative of the bottom, which is d over dx of 7x minus 4x squared, and it's just going to be multiplied by the top, which is x to the half plus 2x. And you're going to be dividing this entire thing by the bottom squared, so it's going to be 7x minus 4x squared squared. So we're going to take the derivatives, and I'm just going to put dot 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 because we're not going to do the entire simplification process. So let's just take it. So it's going to be half x to the negative half plus 2, right? And then this is going to use multiple by 7x minus 4x squared. And then the derivative of 7x minus 4x squared is just going to be 7, subtract out 8x. And then we're going to have here, this stays the same, x to the half plus 2x, and it just gets divided by this, 7x minus 4x squared squared. Alright, so I'm going to put dot dot dot. This can be continued and simplified further, but that's the main part of the derivative. Question 17, it asks us to take the derivative of x plus 1 or divided by tan hx, and I've written down here already that we have a hyperbolic, right? And we're using quotient rule to solve this. So it's going to be the derivative of x plus 1, right, multiplied by tan hx, right, and then you're going to be subtracting out the derivative of tan hx multiplied by x plus 1, and this is all going to be divided by tan h square x, right? So what are we going to do now? So the derivative of x plus 1 is 1, so we're just going to have tan hx, And you have the derivative of tan hx is equal to sec h square x. Sec h square x, and we're just going to be multiplying this with x plus 1. Let me just make that a little nicer. Dividing this thing by tan h square x. So I'm just going to leave it like this for now because it's a little, you might be able to simplify this further, but I'm going to leave it like this for now. Alright, so that's question 17. Now for question 18, we've got the derivative of sine hc plus 2 cos hc minus sec hz. So let's do this. It's going to be equal to, so we're going to take the derivatives individually like so. The derivative of sine hz, in this case, is going to be cos hz. So we're going to get cos hc, right? And if we have 2 cos hz, our derivative 2 cos cos hc is going to be 2 sine hz. So 2 sine hz. And here we have minus sec hz. And if I have minus sec hz, we're going to have plus sec hx tan hx. So that's it for this one over here. Right, so that's it for this one over here. I'm going to actually circle this. So let's circle that. This is our answer. Alright. I also want to question 19, where it asks us to take the derivative of 2 cos x plus 6 cos inverse of x. Remember that the derivative of cos inverse of x is basically equal to negative 1 over root of 1 minus x squared. Because that's a tricky part, the only tricky part to this question actually. So if cos inverse of x is equal to 1 over negative 1 over 1 minus x squared, then 6 cos inverse of x should be equal to negative 6 over 1 minus x squared, right? So let's get that out of here. That was just a side note. So solving this, my answer would be, if I have the derivative of 2 cos x, it should be minus 2 sine x, right? Plus, instead of plus actually, it should be subtracting. So you're going to have subtracting 6 over square root of 1 minus x squared. So that's it for this one. Alright, so here for question 20, we have to differentiate sine square x plus cos square x. This one's fairly simple. If we see a pattern here, so because sine square x plus cos square x equals 1. So we're just going to plug it in here. It's going to be the derivative of 1, which is equal to 0. Okay. Now we have question number 21. It's asking us to find the derivative ln of x squared plus 3x. So in this case, I'm going to do a chain rule. Idea here is where my u is going to be equal to x squared plus 3x. My y, in this case, is going to be ln u. And therefore, my dy is equal to 1 over u. And my du is going to be equal to 2x plus 3. So to solve this, let's just put everything together. We're going to have 1 over u times du. So it's going to be 1 over u times du. So it becomes 1 over u, which is in this case is x squared plus 3x, multiplied by du, which is 2x plus 3 over 1. So I'm just going to put everything together. So it's just going to be 2x plus 3 all over my u value, which is x squared plus 3x. So that's it for this one. I'm going to circle it in red. Oh, I forgot to circle this 0 as well. Let's circle that. Okay, so we have question 23. This is a fairly simple derivative. So it's just going to be 18x squared, right, using power rule, minus 9. And that's it for this one. Circle that. So for question number 24, it asks us to take the derivative of 1 plus 5t over the natural log of t. So for this, we're going to be using quotient rule. So right here, quotient rule. And we're going to follow the steps right now. So we're going to take the derivative of 1, so it's going to be d over dt of 1 plus 5t. right? And just have the natural log t sitting there. And from there, we're going to subtract out the derivative of the natural log of t multiplied by 1 plus 5t. And this entire thing is going to get divided by value of the natural log of t gets squared. So this is going to be basically 5 times the natural log of t, subtract out 1 over t, multiplied by 1 plus 5t, and this gets divided by the natural log of t squared. Alright, so that's that. I'll just highlight that in red for now, but this can be continued, I guess. If you guys can find a way to simplify this further, you could. So I'm going to put dot dot dot. Alright, okay, now for the next one we have the derivative of sine 3x squared. So for this, I think you should use chain rule. So again, I'm going to go through all steps. So the first thing I'm going to do is I'm going to set my u equal to 3x squared. My my y is going to be equal to sine u. So my dy is going to be equal to cos u. Then you need to find your du, which is then equal to 6 x. So now let's put everything together. So it's going to basically be your cos u times du. So it's going to be cos of 3x squared times 6x, which I can just bring in front, so it becomes 6x times cos 3x squared. So that's what I have for this question as the final answer. Now let's move on to this question. It asks us for the derivative of, I guess this is the fifth root of x to the 7th. So I want to rewrite this. It's the first thing I want to do. So this is kind of the same thing as saying we want the derivative of x to the 7 to the power 1 over 5. Now if these are exponent rules, this is the same thing as saying we want the derivative of x to the 7 over 5. Now we're just going to use the regular power rule here. So it's going to be 7 over 5. 7 over 5 minus 5 over 5, which just means 1, right? So it's going to be 2 over 5. And we're going to make 7 over 5 in front, so this is going to be equal to 7 over 5 x to the power of 2 over 5. And that's it for this question. Alright, so here we're being asked to take the derivative of e to the x multiplied by x squared. So let's do this. The way to do this would be y product rule. I'm right here, product rule. Yes, let's get it. So it's going to be the derivative of e to the x multiplied by x squared plus the derivative of x squared multiplied by e to the x. So it's going to be e to the x times x squared plus 2x times e to the x. So and this should be your answer, and it's potentially you could simplify further, but we're just going to leave it like this for now. So I'm going to put a dot dot dot. If you could simplify it, go ahead please. Here we've got the derivative of x cubed plus 2x over x squared. So for this we could potentially use quotient rule, but I want to do a little trick here, and I want to simplify this, but I'm just going to write here simplify. And I'm just going to use I'm just going to simplify it and get to it by regular integration. So it's going to become, I'm going to divide everything by x squared. So it's going to be divided by x squared plus 2x over x squared. And this is x squared by x squared cancels out, so this is what we're left with. And hold up, d over dx, right? So now what we're going to do is we're going to cancel this, and this gets canceled out. It becomes 1. This basically cancels out there. So it's basically going to be the derivative, so I get the derivative of x plus 2 over x. Alright, so now I'm going to rewrite this so it becomes a little simpler. So basically you're getting the derivative of x plus 2x to the negative 1. Now let's do power rule and simplify this. So this is going to be equal to 1 plus 2x, so it would be negative, so we bring down the negative as well, negative 2x to the negative 2, which we can simplify as 1 minus 2 over x squared. if we wanted a positive exponent. But yeah, that's that one. It's the answer here. Circled it. And question 29, we're being asked to take the derivative of a root x times x plus 3 in brackets. So this just tells me, oh, use product rule. Right here, product rule. Product rule. So we're going to do the derivative, so d over dx of x to the half. Oops, I just converted my root x, remember? Root x is equal to x to the half. Okay, so we're gonna get rid of that. So we're gonna get x, or derivative of x to the half multiplied by x plus 3, and then we're gonna add to it the derivative of x plus 3 multiplied by root x. I'm just going to keep it as root x because I'm not going to simplify it any further. So the derivative of x to the half is half x to the negative half multiplied by x plus 3 plus derivative of this is going to just be it's just going to be 1, so it's just going to be plus root x. So this should be our final answer for question, our final answer for question 29. There we go. Alright, so for question 30, we have the square root of 2x minus 3x to the power of 5. So in this case, my u is going to be 2x minus 3x to the 5th, where my du is going to become 2 minus 15x to the 4th. And my y is going to be equal to u to the half, therefore my dy is going to be equal to half u to the negative half. Okay, so let's get to doing this. So this is going to basically be equal to half times my u, which is 2x minus 3x to the 5th, times to the negative half, times my du, which is 2 minus 15x to the 4th. And that's it. It's the 4th, by the way. Yep. So that's our answer. You could potentially simplify it further, but I'm just going to put a dot 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 here for now. Okay. Oh, here's a really straightforward one. Here it's saying take the derivative of 24, right? It's a constant value, so the derivative is 0. There we go. Simple. Now we have the derivative of the natural log of 2x. For this we can use another chain rule. So in this case my u is going to be equal to 2x, and therefore my du is going to be equal to 2. My y is going to be equal to the natural log of u. dy is going to be equal to 1 over u. Right? So it's going to be 1 over u times du. So it's going to be 1 over 2x times 2, which is 2 over 2x. So cancel those out, where you get an answer of 1 over x. And that's that one. So here for question 33, it has to see a derivative of x squared minus 1 over x minus 1. And instead of using quotient rule, we might do that, right? You might see, oh, we have to use quotient rule for this one. But instead of doing that, what we're going to do is actually simplify it. And if you guys haven't already noticed, we're going to be using difference of squares. So 5x squared, right, minus 1, it's basically equal to x plus 1 multiplied by x minus 1, right? And this is all being divided by an x minus 1. So these x minus 1s will cancel out. So all you're left with is x plus 1, which is a very simple derivative. Something important to note is that some teachers may ask you to implement a restriction. And the restriction in this case is x can't equal 1. Right? So we're going to get the derivative of x plus 1, which is basically going to be equal to 1. And I'm going to write this for all x can't equal 1. That's it. Right? It just depends on the teacher and the question they're asking for. Alright, so the next question we have is x times sine x. So here, this instantly comes out to me as product rule. So let's get to it. So in this case, we're going to take the derivative of x. So we're going to take the derivative of x multiplied by sine x plus the derivative of sine x multiplied by x. So we're going to get sine x, because the derivative of x is just 1. We're going to get sine x plus cos x times x. And you could potentially simplify this further. I'm gonna put dot dot dot, but that's up to you guys. So there we go. Boom. All right, let's keep going. Let's go down. Okay, so now we have that's the derivative e to the z plus 1 tan z. So to do this, what I would want to do is actually understand that it's product rule. Again, look at that. That's pretty good for us. So let's use product rule one more time. So it's going to be the d over dz, the derivative of e to the z plus 1, multiplied by tan z, plus the derivative of tan z times e to z plus 1. Alright. So the derivative of e to z plus 1 is just going to be e to z times tan z. And the derivative of tan is going to be sec squared z. Sorry, sec squared z. And this is going to be staying the same as e to z plus 1. Well, that z is very small. Let's make z plus 1. And if you guys want to simplify it, go ahead, please do so. I'm going to highlight this in red. Alright, so that's that. Alright, so for question number 36, we're going to be taking the derivative of sine x over x, and for that we're going to be using quotient rule. So we're going to be taking the derivative of sine x, multiplying this by x, subtracting out the derivative of x times sine x, and you're going to be dividing this all by a value of x squared. Derivative of sine x is cos x, so cos x times x, subtract out the derivative of x is 1 times sine x, so it's minus sine x over x squared. So if you guys can simplify it, simplify it. So I'm just going to box it out here for now. That's your answer without simplification. Alright, so here's the derivative of e to the x over x plus 1. So again, this is a quotient rule problem. Quotient rule. So it's going to be the derivative of e to the x multiplied by x plus 1. Subtract out the derivative of x plus 1 times e to the x over x plus 1 squared. So it's going to be e to the x times 1, right? So we don't have to write that, but just times 1. Subtract 1, so e to the x minus e to the x, correct? Over, actually, sorry about that. It should be e to the x times x plus 1, subtract e to the x, like that. And it's all being divided by x plus 1 squared. So that should be what it is. I'm going to circle it out. Alright. Now we've got e to the 3x. So for this, we could use a chain rule type solution. So we're going to be setting our u to 3x. So then your du becomes 3, and our y equal to e to the u. So therefore our dy is still going to be e to the u. Correct? So from this we can start inputting what we need to know. So it's going to be dy. So it's just going to be, we're going to have e to the u times du. So it's going to be e to the 3x times 3. So our answer is 3, e to the 3x. And that's it for this question over here. Sometimes I like to put easier integrals in between some more difficult ones. Here we have a straightforward one, which is just 16x cubed, right, power rule. And you would apply power rule right here, it will be minus 15x squared, right? Subtract 1, multiply, we know the rules. And then it would be plus 2. So it would be 16x cubed minus 15x squared plus 2. So let's just highlight that. And 7 wouldn't even be there. You get, it's a constant, it would be 0. So this would be our answer for this. Okay, now let's go down here. Let's do this. We have the derivative, trying to find the derivative of tan inverse of x squared. So how do we do this? Something important to understand, right? It might be given to you. If you have a formula sheet on your test, it might be given to you. If not, you'll have to know this by yourself. When we're taking derivatives of tan inverse of something, this is a general outline I like to follow. You would have 1 over 1 plus your u squared, right? And you just multiply that with your du over dx. Now what do I mean by this? So if I'm taking the derivative here, it would just be 1 over 1 plus u squared. So what is my u in this case? I'm setting my u going to be to x squared, right? It's kind of like a chain rule type of problem, right? It is a chain rule. So u would be x squared, right? Multiply that by du over dx, which is a derivative of x squared, which is going to be 2x, okay? So we're going to put everything together. It's going to be 2x over 1 plus x to the 4th, right? Oops, that x does not look good. Let's do that. Okay, there we go. So as simple as that, we've solved it. So I just like to remember this. It makes life way easier for these inverse type stuff, especially tan inverse. Okay, so that's that. Here we go. Now on to the next one. For question 41, it asks us to integrate, derive e to the 2x times the natural log of x. Oops, bracket problem there. So remember for question, I believe it was question 38, if we go back a few times here, we did the same type of thing, right? We performed the chain rule, but performing the chain rule can take us some time, right? But it's good, if we can do this mentally, it saves us time. So you can see what happens here. We brought our number up here down, right? So let's do that. Same idea here. And we're taking the derivative of e to the 2x. And if you guys haven't noticed already, we're using product rule. Product rule. So everything should be fine. So let's do this. So it's going to be equal to the derivative d over dx of e to the 2x. E to the 2x multiplied by the natural log of x plus the d over dx of the natural log of x multiplied by e to the 2x. There we go. So remember, if we have e to the 2x, we're just going to bring our 2 down, so it becomes 2e to the 2x. That's it. As simple as that. Times the natural log of x plus the derivative of natural log of x is 1 over x, right? Multiply that by e to the 2x. Now I believe there could be some ways to simplify this, but I'll leave that up to you. Put a dot 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 if you guys want to simplify it. But yeah, I'm going to circle this out. And that's it for 41. For question 42 here, where we asked to take the derivative of x to the 4 times e to the x squared. So again, here we're going to be using chain rule and product rule. So for here, I'm not going to show all the steps for chain rule. I'm just going to show like a general idea. Since we did so many questions on chain rule, I think we should get like the general idea really quickly. So what we're going to do is we're going to take the derivative d over dx of x to the 4th, right, times e to the x squared plus the derivative d over dx of e to the x squared multiplied by x to the 4th. So the derivative of x to the 4th is simple. It's just 4x cubed, right, times e x squared. And now the derivative of e to the x squared, if we use chain rule, to understand that all you have to do is take the derivative of whatever this top one is and bring it down for this e. So it'll just be 2x e to the x squared times x to the 4th. And so this should be what it is. And you could potentially simplify it further, I'm pretty sure. But check it out, try it out. I'll put a dot 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 to be continued. Alright? Okay. So now we're being asked to take the derivative of x squared times sec x. Now, the only tricky part here, other than using product rule, is to understand that the derivative, right, the d over dx of sec x is equal to sec x tan x. Once you know this problem becomes fairly easy. So, again, this is product rule right here. Product rule. So therefore, it'll basically be equal to the derivative of x squared times sec x plus the derivative of sec x times x squared. So it's equal to 2x times sec x plus sec x tan x times x squared. So this is it. This is potentially, again, you can try and simplify, see if you can simplify this further. I'm going to put dot dot dot. Okay. Here we have a fairly simple trig derivative. So again, you just individually take the derivative of each of these and put it together. So the derivative of sine x is cos x. So I'll just do it straight up. So it'll be cos x. And then the derivative of cos x, derivative of cos x would actually become negative sine x. So we have subtract negative sine x. So it's going to become cos x plus sine x. I guess the only tricky part about this problem is understanding these signs here, making sure when you're given the final answer, it makes sense, right? So that's going to be question 44. Question 45 asks us to differentiate 8 sec x minus 5 cos x. So when we can do this is we can just take out these constants out first, so it'd be 8, and we're taking the derivative of secant x. And then you can take out a 5 here, this is a constant, put in cos x. Okay. Now what we need to do is actually take the derivatives, right? So we have 8, and the derivative of secant x is sec x tan x. And the derivative of cos x is minus 5 sine, so it'd be negative sine x. Alright, so if we simplify this even further, we can distribute this to here. So basically we get 8 secant x tan x, and this negative file will distribute here, so it'll be plus 5 sine x. So that's it for question 45. I'll box it. Okay, now let's look at question 46. So question 46 asks us to differentiate 2 to the x times x cubed. Now the only difficult part of this problem is to apply chain rule to 2 to the x. So just to make life easier, if we know what 2 to the x is, the d over dx of 2 to the x, which is basically going to be giving us 2 to the x times the natural log of 2, right? All we need to do is plug this in. Where will we find the when we have the derivative of 2 to the x? So again, we're using product rule. So it will be the derivative of 2 to the x multiplied by x cubed plus the derivative of x cubed multiplied by 2 to the x. So from here we would get an answer of 2 to the x times natural log of 2 times x cubed plus 3x squared times 2 to the x. I'm gonna hide that. You can possibly simplify this further, but that's on you guys, as usual. I'm gonna put a dot dot dot. Here we have a pretty fairly simple derivative. So what we want to do is just divide by 2. All these are divisible by 2, so just divide all of them by 2, and you basically get the derivative of x squared plus 2x cubed plus 3x. And this is going to be giving us 2x, right, plus 6x squared plus 3. Rewrite this in a way that's better. In the correct order, it should be like so. So that's it for this derivative. So we're almost near the end, and of course we save the hardest for the last, so let's get to it. So to take the derivative of x cubed times e to the x squared times the natural log of x, what you would actually want to do is, it is product rule, but it's a product rule with 3 parts in it, so you basically do kind of the same thing. You would take the derivative of this and keep these the same, right? And then you'd add on, go to the next part of it, and you'd take the derivative of this and keep these 2 the same. And then you would want to take the derivative of this and then keep this and this the same. So I'll show you what this is like by drawing this out. So it would basically be, I'll just right here, 3-term product rule. Product rule, put right here. Okay, So basically you'd be taking the derivative, so it'd be d over dx of x cubed, let's say, and then you basically keep e to the x squared times the natural log of x the same, and then to that you add in the derivative, the d over dx of e to the x squared, right? But yet you're going to keep the sorry, you would keep the other ones the same. So you'd keep the natural log of x the same, and you would keep the x cubed the same. And for the final part of it, you would want to add, basically you take the derivative of e to the x squared and the x cubed, right? You take the derivative of ln x. Next you take the derivative of ln x, natural log of x, right? And then you keep the others the same, which in this case are e to the x squared and what was it, x cubed. Alright, so let's get to simplifying this. This is quite the big one, but let's get to it. So this is going to be 3x squared, right? The derivative of x cubed 3x squared times e to the x squared times the natural log of x, right? And to this we're going to add the derivative of e to the x squared is going to be 2x times e to the x squared. Remember, we talked about this before. And this is going to be multiplied by natural log of x times x cubed. Sorry if this looks a little bit messy. I'll try and circle everything at the end. So then, this is continuation, by the way, from here. So plus the derivative of natural log of x is 1 over x times e to the x squared times x cubed. So that's it for this one. I'll try and circle it up. There we go. Alright, so that's it for 48. So for this question, it looks a little bit similar to the last one, but again, we are using product rule, but we kind of have two terms. Like, overall, we're going to kind of have two terms at the end where we add together. I kind of say two terms, but it's not really two terms. But I'll show you what I mean. There's different ways to solve this, of course, but what I'm going to be doing is I'm going to be taking product rule here, I'm going to PR for product rule, and also product rule here as well. And at the end, just putting a plus sign between them. Alright, so let's do this. So this is going to be, I'm going to do this side first, so it's going to be the d over dx of x squared times the natural log of x, right? And to that we're going to be adding the d over dx of natural log of x, correct? D over dx natural log of x, and then we're going to be multiplying that with x squared. So that's our first thing. We're going to simplify it, and we're going to get from, I'm going to put blue for first equation. So we're going to get from that 2x times the natural log of x plus 1 over x times x squared. Alright? So we could simplify this further. We get 2x times the natural log of x plus, you get x squared over x, so we just get x. Alright, so now let's do part 2. So I'm going to put, this is part 1 here, and equation 2 is going to be this one. I'm going to get pink, okay? So that's that. So let's do equation 2 over here. So it's going to be the derivative. So let's do d over dx. Oops. D over dx of, in this case, it's e to the x, right? So it's going to be e to the x times sine of x plus the derivative, d over dx of sine of x times e to the x. So e to the x is e to the x, sine x stays the same here, and we're going to be adding the derivative of sine x, which is cos x, and we have times e to the x. Okay, now all we're doing is going to combine these two together over here. Okay, so equation 1 plus equation 2, in this case, we'll basically get as a big equal sign. I'm going to actually make it look out like a blue equal sign. Actually, no, let's do a green equal sign for the final part, which is basically going to be 2x times the natural log of x plus 1 over x. Oops, never mind. We already simplified it. Just plus x. And when we adding, remember this plus sign goes in here. It'll be e to the x times sine of x plus cos x times e to the x. And that should be our answer in this case. So here is our final question here. I'm not going to try and simplify this as much, right? So you'll see why I'm not going to be simplifying it. It gets a little bit convoluted, so I'm going to keep it as is when I get it. Okay? So here we can see that there's a product rule happening up here. So whenever it asks for the derivative of, so remember, when we're using quotient rule, right? This is quotient rule in totality, right? So this right here is going to be my f of x, and this is going to be my g of x. Okay, so first things first, we're going to be taking the derivative of this. So it's going to be the d over dx of x squared times e to the x cubed, right? And it's going to be multiplied by the natural log of x, correct? And then we're going to subtract out of it the derivative, d over dx, of natural log of x, right? Oops, I'm doing my derivatives a little wrong. You should actually just put it in your bracket so you don't get confused. My fault, guys. Let's do that. Let's get that. And let's do that. There we go. For the derivative of this thing, right? And then we have this natural log of x. Subtract the derivative of the natural log of x. Again, I'm making this issue. So let's just get rid of that. Boom, 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 right? And so, and then we're going to have this multiplied by x squared times e to the x cubed. And it's going to get divided all by the natural log of x squared. Okay, so now all we have to do is apply the product rule and plug it in. So I'm going to pick a little area here, call it product rule. Okay, there are ways to do this in just one singular step, but I like to do it this way. Alright, so here we're taking the derivative here, so it would be 2x, okay, hold up, so we do product rule of 4, we're taking the derivative of, what is it again? It is x squared times e to the x cubed. Hopefully that's right. So, when we take the derivative of this, we're going to do the derivative of this first, so it would be 2x, right, multiplied by e to the x cubed, right, plus x squared stays the same, and then we have e to the x cubed actually just becomes 3x. When we take the derivative of this, it becomes 3x times e to the x cubed. All right. Sorry, hold up. It becomes 3x squared times e to the x cubed. Sorry about that. So now that we've done this, all we have to do is just plug this back in to our equation there, right? So let's do that. Let's plug this thing. Basically, it's going to go in here and over here. Sorry, not there. Only in there. Only in there. So let's just write this entire thing out. So this is going to be, I guess I'm going to put the blue. I'm going to use blue to write out the entire thing. This is the final. So the final thing is just going to be 2x times e to the x cubed plus x squared times 3x squared e to the x cubed multiplied by natural log of x. Oh, I don't think I can fit this entire thing here, but we'll see. Natural log of x, subtract, we have the derivative of the natural log of x, which is 1 over x, right? So check those brackets. 1 over x times x squared times e to the x cubed, right? And this is all going to be divided by natural log of x squared. So this should be the final answer. I mean, not simplified, of course, leaving it as is, because simplifying this would, you know, be a little bit hectic, but it's definitely possible to simplify it. But yeah, that's it for this video. Hope it helped, and have a good day, guys.